Last time we have studied about the properties of acids and bases. Today we will do further about that. The first one is acidity of a base and the second is basicity of an acid. Now what is the meaning of acidity of a base? Acids are classified as monobasic, dibasic, tribasic. It depends on the number of hydrogen atoms. Acids are classified as monobasic. Like HCl contains one hydrogen, therefore it is monobasic. H2SO4 contains two hydrogen, therefore it is dibasic. And H3PO4 contains three, so it is dibasic and it is tribasic. So now why we say acid has got basicity, dibasic, monobasic? Because if this HCl is to be neutralized, we need one NaOH. Understood? Or in other words, how many hydrogen ions are there? So that much amount of hydroxyl ions are needed. How many hydrogen ions are there? That much amount of hydroxyl ions are needed. That is why they said this way: number of hydroxyl ions needed to utilize one molecule of acid. Or in other words, simply you can understand how many hydrogen ions are there. That much is its basicity. But how do we say? How do we define it? It is the number of OH minus ions needed to neutralize one molecule of the acid is known as its basicity. Or in other words, you can say that how many NaOH molecules are needed? You know that NaOH is a base. Understood it? So how many NaOH molecules are needed to neutralize one molecule of the acid is known as its basicity. Have you understood it clearly? So HCl is monobasic, which needs only one NaOH. H2SO4 needs two NaOH to neutralize it, and H3PO4 needs three NaOH to neutralize it. And that is why the basicity of an acid. Understood it? And vice versa, for a base we say it is acidity. Now, for example, NaOH, it has got one OH minus, and that is to be utilized in one HCl. So, how do we say the acidity of a base? It is the number of hydrogen ions needed. Now, remember we have studied it earlier. Acids are compounds which have got hydrogen ions, displaceable hydrogen atoms, or which have got hydrogen ions. So, OH minus is to be utilized. This gives H plus. So OH minus is to be neutralized, which needs H plus, therefore we need H2O. Understood clearly? So the definition don't get confused. Acidity of a base and basicity of an acid. Understood it? So NaOH is monoacidic base. Calcium hydroxide is diacidic base. Aluminum hydroxide is triacidic base. So what is the basicity of an acid? Number of OH minus ions needed to neutralize one molecule of the acid. And what is the acidity of a base is the number of H plus ions. H plus ions that are present in acid to neutralize a base. Okay? This is about acidity and basicity of an acid. The next term that we need to do about is the pH. We did study that earlier. So let's study it in detail since we have time. So pH is defined as potence hydrogen. Potence hydrogen ion. That means potence is strength. It is the strength of hydrogen atoms present. The strength of hydrogen atom present is known as pH. The strength of hydrogen atoms. For example, how we say that pH is known as minus logarithm of hydrogen atom concentration. So mathematically we say that logarithm minus logarithm of hydrogen atoms. Now let us understand it. Logarithm meaning is, you will study it later. Logarithm means, suppose we say that 10 to the power of 3 is equal to 1000. And if you are going to write it in the form of logarithm, what we say that logarithm of 1000, when it is factorized to the base 10, the answer is 3. So what is the log of 1000? 1000 to the base 10, it is equal to 3. So this is how we find the logarithm. Any number, when the base is given, the exponent becomes a logarithm. For example, 2 to the power of 5 is equal to 32. Right? So 2 to the power of 2, 5 times multiplied, we get 32. So therefore, we can say that this is to be expressed logarithm of 32, when it is prime factors to the base 2, then the exponent is 5. So what is the answer? Log of 32 to the base 2 is equal to 5. This is how we get the log. And what is pH? Minus log of hydrogen ion concentration. Understood it? Now let us find out. Let us do the calculation. For example, we need to find, suppose like you have got 10 to the power minus 3 molar HCl. You are studying 9th standard molar. Number of moles dissolved in 1 liter is known as 1 molar. Number of moles you are studying in class 9. So 10 to the power of minus 3 molar HCl. 10 to the power of minus 3 molar HCl. That means, what does it mean? 1 mole of HCl will be giving 1 hydrogen ion. And when it is 10 to the power of 3, we will be getting 10 to the power of minus 3, we get 10 to the power of minus 3 hydrogen ions. Understood the amount of hydrogen ions, how we calculate it? 10 to the power of minus 3 molar HCl is taken. The strength is 1 molar HCl will give 1 hydrogen ions, and 10 to the power of minus 3 will give 10 to the power of minus 3 hydrogen ions. Alright, therefore, pH is equal to minus log of 10 to the power of minus 3. Understood it? And what is the log of 10 to the power of minus 3? Is minus 3. Therefore, how much is the pH? Minus into minus 3. From where does this minus comes? The logarithm is minus 3. So minus of minus 3, therefore the pH is equal to 3. Understood how we calculate it? Calculation is not a part of the syllabus, but it is better you know. So the amount of hydrogen ions present expressed in the form of 10 to the power, and its minus is written. Understood it? One more example. 10 to the power of minus 6 moles of HNO3. So 1 HNO3 is 1 hydrogen ions. So 10 to the power of minus 6 moles will give you 10 to the power of minus 6 moles of hydrogen ions. Understood it? Therefore, how much is the pH? pH is equal to minus log of 10 to the power of minus 6, that is equal to minus into minus 6, therefore 3 is. Calculation is not part of the syllabus, but better you know. So pH is given the strength of hydrogen ions. How we calculate it? The strength of hydrogen ion, which is expressed in the form of log. So minus log of hydrogen ion is the pH. Clear? Now, the numerical aspect of pH is not there in the syllabus, but the qualitative aspect is there in the syllabus. Understood? Qualitative aspect means when the pH is equal to 7, it can be more than 7 and it can be less than 7. So there are 3 options. Now understand it further. H2O contains equal number of H plus and OH minus ions. H2O contains equal number of H plus and OH. And it has been calculated that the hydrogen ions in H2O is 10 to the power minus 7 and hydroxyl ion is also 10 to the power minus 7. Therefore, for any neutral solution, pH is equal to 7 and that means it is neutral. So, any neutral solution pH is equal to 7. So, what do we say that? When the pH is equal to 7, it is neutral. And when the pH is more than 7, it is basic. And pH is less than 7, it is acidic. So, remember, the pH is equal to 7, the solution is neutral. More than 7, it is basic. And less than 7, it is acidic. You understood it? This is how we calculate the pH. When the pH is equal to 7, the solution is neutral. More than 7, it is basic. Less than 7, it is acidic. Now, let us find out further about this. Now, when we say that pH, suppose like here, probably say that the ionic product of H2O, ionic product of H2O is equal to 14. What does it mean? H2O contains H plus and OH minus ions. So it has got 10 to the power of minus 7 and into 10 to the power of minus and OH minus. Therefore, its ionic product is when we take out the pH, it becomes multiplication, the power is added, it becomes 14. So for any solution, understood, which has got H plus and OH minus ions, the total pH would be 14. Remember that. Total pH would be 14. So if the pH is equal to total product is, if the pH is equal to total of pH product, don't know. So if the pH is equal to 4, then pOH is equal to 10. Understood? And if the pH is 7, pOH is 7. If the pH is 10, pOH is 4. So the product of pH and pOH in the logarithmic form, it will always be equal to 14. So if set the pH of a solution is 6, how much would be its pOH? When it is 6, the pOH would be summum. So 14 minus 6, it is 8. Now let's take it this way. When the pH is equal to 6, how much is the strength of hydrogen ion? The strength of hydrogen ion is 10 to the power minus 6. And how much is the strength of hydrogen ion? 10 to the power minus 8. So 10 to the power minus 8 is less than 10 to the power minus 6. That means 10 to the power minus 6 means it has got more amount of hydrogen ion. That means it shows acidic nature. And that is why I told you, if the pH is less than 7, it is acidic. If the pH is more than 7, it is basic. And if the pH is 7, it is neutral. Have you understood it clearly? This is how the pH is analyzed. The next one. pH is found with the help of universal indicator paper or known as pH paper. pH is found with the help of universal indicator paper or that of which is known as a pH paper. It is a strip of paper, and that strip of paper has got somewhat like this color, light brownish, whatever color you say that is the color. So on that pH paper, when we put the solution onto the pH paper, when a drop of the solution is added, immediately the color of the pH paper gets changed, and you see the color. And if the color comes in the red band means red, pink, in that manner it is going on. And if it is in the red stream, red band, then we can say the solution's pH will be less than 7. And if the color is gray, changing to gray or bluish in color, bluish, gray, etc., the color difference is there. So when it is changing into red band, it is less than 7, it is acidic. And when it is into the gray band or bluish, then it will be basic, that means the pH will be more than 7. So, simple experiment, take this drop of liquid solution, put it on the pH paper and see what is its color. The color is changing to red, that means red means you can have dark red, light red, pink and all these different types of red shade. Then it will be acidic in nature, that means pH will be less than 7. How much less the pH? Say for example, we have got the pH 6, it may be a little darkish pink. And if the pH is 1, it will be dark red. So as the strength of hydrogen ion gets increased, the color of the paper will be more and more darker. Vice versa for a base. And when it is put, the color of the paper gets changed into grayish, bluish and dark bluish. That depends on the pH. Understood? This is how we find out the pH. pH is found out with the help of pH paper, which is known as universal indicator paper. Every pH paper is supplied with a chart. Every pH paper is supplied with a chart. So what do you need to do? Put the solution onto the paper and see, match the color, and that is the simplest experiment. And remember, when the pH is less than 7, color will be in the red, that means acidic one. And when the pH is more than 7, it is basic, it will be in the grayish bluish shade. Understood it clearly? The product of hydrogen and hydroxide ion in any solution is going to be 14. Understood it? So in the book it is mentioned 0 to 14. It can vary from anywhere. Suppose like if the hydrogen ion concentration is 10 to the power of, so for example, the hydrogen ion concentration is 10 to the power of plus 3 HCl. It is plus 3. So how much is the hydrogen ion? Hydrogen ion is 10 to the power of plus 3. And how much is the pH? pH is equal to minus log of 10 to the power of 3. That is equal to minus into 3. So the pH will be minus 3. So don't just think in this way that pH should be coming in 14. It depends on if we are taking stronger acid. Suppose like 10 to the power of 3 molar HCl. How stronger it is? 1 mole in 1 liter is 1 molar. So 3 moles in 1 liter is 10 to the power of 3 molars. Naturally, it will be a more amount of hydrogen ions. And when it is 10 to the power of 3, the hydrogen ion strength also will be 10 to the power of 3. And when we find out the pH is going to be minus 3. So that is how we find out the pH. Understood it? So remember, the ionic product of any solution is 14. Every solution is, supposedly when it is a solution, it is made dissolved in water. So every solution contains hydrogen and hydroxide ions. When hydrogen and hydroxide ions are naturally, both will be having pH and pOH. Understood it clearly? So this is about the pH, and pH we find out with the help of pH paper. pH paper will be provided with the chart. Without chart, we can find out it. Put the solution onto the paper. When the paper is wet, you see the color. Don't wait for the paper to dry. Now, as the paper gets dried, what happens? The water molecules are gone, then the color of the paper naturally change. So pH is to be detected only when the paper is wet. Understood it clearly? This is about the pH. Clear? The next one. Strong acids and weak bases. Strong acids and strong weak acids. Like normally we say inorganic acids are strong. HCl, HNO3, H2SO4 are strong acids. And in chemistry it is defined as, what is a strong acid? When HCl is put into water, it is dissociated into H plus and Cl minus. So this is what is known as strong acid. So strong acids are those which dissociates completely. So HCl is dissociated into H plus and Cl minus. That is what is a strong acid. Understood? HNO3 is also getting dissociated completely, so we will be having H plus and NO3 minus. This is what is strong acid. So any acid which dissociates completely into its side is strong. That means when it is put into water. And weak acids, say for example H2CO3. This is a weak acid. Its dissociation is partial. Don't just think that it will not produce hydrogen ions. Weak acids are those which dissociates partially. That means hydrogen ions and CO3 minus ions are separated, not fully separated. HCl is taken, it is dissociated completely. It is separated into H plus and Cl minus in water. Therefore, we call this as a strong acid. And H2CO3 dissociation is partial. Therefore, we say it is a weak acid. Understood it clearly? Similarly, strong bases are known as alkali. Say for example, NaOH is dissociated into Na plus and OH minus. It's a strong alkali or a strong base. And bases are weak, it dissociates partially. For example, aluminum hydroxide, it does not dissociate completely, therefore aluminum hydroxide is a weak base. Clear? So strong acids are those which dissociates completely, weak acid which dissociates partially. Strong bases are those which dissociates completely into the ions, and weak one which dissociates partially. This is about the definition of strong and weak acids. Alright? Now next topic. When a salt is obtained, how do we get the first chapter? We are studying the reaction of neutralization. First chapter we are studying about the reaction of neutralization. So it's a reaction where an acid is neutralized by a base or an alkali. An acid is neutralized by a base or an alkali. Let's see. An acid is HCl and the base is NaOH or alkali. What happens? We get H2O plus NaCl. So this is strong acid and this is strong base. When strong acid and strong base are reacted, we get neutral. So NaCl solution is produced. So this is a question which you can likely to get. What would be the effect of pH paper onto aqueous solution of sodium chloride? Understood it? Aqueous solution of sodium chloride, you put a pH paper, the color will remain somewhat like dirty greenish in color. That is a pH of 7. When the pH is 7, color will be in the greenish in color. So the color of pH when the solution is neutral is green. Therefore, NaCl is neutral because it is a product of strong base and strong acid. Therefore, its pH will be 7. Understood it? So, any salt that is obtained by the reaction of neutralization between strong acid and strong base is neutral. For example, one more one. Na2SO4. Na2SO4 is obtained by the reaction between NaOH and H2SO4. Na2SO4 is obtained by the reaction between NaOH and H2SO4. So, what is this? Is strong base and this is strong acid. Therefore, its pH will be 7. Understood it well? So, the product obtained by the reaction of neutralization between strong acid and strong base is neutral, and when it is neutral, its pH will be 7. Clear? The next one is, let's take it. HCl and NH4OH. NH4OH is a weak base and this is strong acid. NH4OH does not dissociate completely in its acid, therefore we get the salt NH4Cl. NH4Cl are strong acid. Strong acid means NH4Cl solution will be acidic in nature, that means its pH is going to be less than 7. So aqueous solution of NH4Cl will change the color of pH paper to red because it is the product of strong acid and weak base. Understood clearly? Now strong base and weak acid. So for example, NaOH is a strong base and S2CO3 is a weak acid. So you will be getting Na2CO3, washing soda or baking soda. So its pH will be more than 7. Its pH will be more than 7 because strong base and weak acid. Strong base is NaOH, S2CO3 is weak acid. Therefore, the product whose pH will be more than 7. More than 7 means basic. Understood it? And that's the reason what has happened when the bee sting is there, which will be having formic acid going, and we put washing soda to neutralize the acid. Because washing soda is basic in nature. Washing soda is basic in nature, so it gets neutralized. Understood it clearly? So this is whether we have to find out. So you may get a question like this: what would be the effect of pH paper or litmus paper, etc., onto the solution of aqueous solution of sodium chloride, aqueous solution of ammonium chloride, aqueous solution of sodium carbonate, etc. Understood it? Or in other words, it will be asked: aqueous solution of sodium carbonate is basic in nature. Give reason. And what reason will give? Sodium carbonate is a product obtained by the reaction neutralization between strong base NaOH and weak acid. Strong base NaOH and weak acid, therefore it is basic in nature. And this is the method one need to do it. Have you understood it well? Strong acid, strong base neutral, weak acid, weak base neutral. That is also one example. I will take it out this one. What can we take it as a weak base NH4OH plus S2CO3. This is weak base, this is weak acid. So we will be getting NH4 or twice CO3. So ammonium carbonate. So aqueous solution of ammonium carbonate is neutral. So few examples which are given in the book, you should know that. Strong acids, normally we take it as mineral acid, HCl, HNO3, SO4. And strong alkalis, NaOH, KOH, calcium hydroxide, few. And rest all you can take it as weak acid. S2S, S2CO3, all these things you take it as weak acids. Understood it well? That's the method of doing that. Okay, the next one is okay, so we are studied about the pH and the strength of the pH and everything is studied it. Now the next term is importance of pH in our day-to-day life. Normally pH comes to our life quite often, and one such one is plants, our body works efficiently when the pH is between 7 to 8. Therefore, living organism can survive only in this pH range. Understood? You know that acid rains, non-metallic oxide like nitrogen dioxide or sulfur dioxide get dissolved in water, and that comes in the form of rain, and then we call that acid rain, which will be producing itching and etc. or burning sensation in the eyes, and that is because its pH is less than 7. So when these oxides dissolve, its pH is going to be near to 5.6. That means its pH is less than 7, and less than 7 means acid, and that is what we say that acid rain. Like the brilliance of Taj Mahal is lost due to the coal industries which were there long time back in Agra region, because when the coal used to get burned, it will be producing a lot of nitrogen dioxide and sulfur dioxide along with carbon dioxide. The carbon dioxide does not cause so much amount of harm because carbonic acid is unstable, whereas sulfur trioxide dissolves in water to produce sulfuric acid, and when the acid falls down on the marble, the reaction double displacement takes place. Understood it? So that is it. The next one is digestive system. You know that your stomach secretes hydrochloric acid. Stomach secretes hydrochloric acid. That is to kill the germs present when we eat. All these bacteria and other germs are to be killed. Therefore, automatic secretion of HCl take place. And excess amount of HCl will produce acidity problem. That is why people, doctors say that you must have the breakfast. Isn't it? All night nothing is eaten, your stomach is empty and the secretion of acid take place which will be producing acidity. So one should have breakfast to prevent that. Anyway, this excess amount of acid secreted in the stomach creates acidity, and that acidity can be rectified only by an acid can be neutralized only by a base. And there's nothing can be done. So we must consume the things which are basic in nature, and that is what acidity problem is. And such substances which reduces the acidity or which neutralize the acid present in the stomach are known as antacids. Antacids, understood it? What are antacids? Which neutralize the acids. And what can neutralize acid? Only bases or alkalis. So we cannot consume sodium hydroxide because it's a strong base that will burn the internal organs. So we cannot. So we can have like weak alkalis, like magnesium hydroxide. You know that acidity problems, doctors prescribe milk of magnesia, hygiene. All these things contain hydroxides of magnesium or aluminum. So when we have hydroxide of aluminum going inside, it gets reacted with the salt. And when magnesium is taken, magnesium is a micronutrient needed by the body. So magnesium hydroxide, you are taking it inside, and when it is reacted by the acid, the magnesium salts are produced that get absorbed, and one gets this acidity problem decrease. And remember, acids can be neutralized only by a base. Understood it clearly? So our stomach has got acid, and that acidity produces severe pain, and that get neutralized only by taking. Persons suffering from acidity are also advised milk which is alkaline. You know that when the milk is removed, its pH is somewhat like 6 point something, and you have to make the pH of milk more than 7. So when you consume cold milk, the acidity problem will be decreased. Understood it clearly? The next one is tooth decay. The strongest material in our body is tooth enamel. Understood it? And the tooth enamel get reacted by the acid. Understood it? The food materials left out in our stomach by the action of bacteria get converted into carboxylic acid. And these carboxylic acid react with the enamel, and the enamel is degraded, decomposed, and that is how the tooth decay begins. And that's the reason why we must brush our teeth after meals with toothpaste. The toothpaste is always alkaline. Toothpaste is always alkaline. So what has happened? That will keep the pH of milk more than 7, pH of saliva more than 7. And when the pH is more than 7, what is likely to take place? The tooth decay does not take place. So one should have that one. Understood it? Self-defense by animals and other things there. Understood it? These are the things which are given in the NCERT book. One should know that. You know that as I told you earlier, bee stings contain formic acid. The best remedy is that area to be rubbed with washing soda or baking soda, which are any alcohol, or even we can use slaked lime or calcium oxide solution can be applied, and that will neutralize the acid. Understood it? This is all about pH and other things. Next we need to do about the salts. Salts. Salt is a product obtained by the reaction neutralization between acid and base. Salt is a product obtained by the reaction between acid and base. So we'll do about the salts and classification. Already we are done it. Strong base, strong as neutral salt, acidic salt, and basic salt. Understood it? Let me see the syllabus, what is present. Preparation, okay. Logarithms we have studied. Now we need to do about the preparation of certain compounds which are needed: sodium hydroxide, bleaching powder, baking soda, and washing soda. All right. So that we'll take it in the next class.